Alright, this is going to take the whole time. So, sit down. Let's go. Hyperbola. Fun part is, it's very, very, very similar to our ellipse. Okay? All the relationships that we saw within the ellipse, we're going to see very similar relationships in the hyperbola. Okay? Essentially, when we have an ellipse and we want a hyperbola, what we're doing is kind of splitting it and then turning it outwards. And so just kind of think of the ellipse, instead of it closing in on itself, it's going to open outwards. Alright? The equation is almost identical, except for it's a minus sign. Instead of a plus sign, it's a minus sign. Alright? Other than that, a lot of the relationships are very, very similar. We're going to go through a couple key things to note. First, in the ellipse, A had to be the largest denominator. Okay? That's not the case in the hyperbola. Okay? A will always be the first denominator because now we have subtraction. In the ellipse with addition, the order of the terms doesn't matter because the order of addition doesn't matter. That's why we needed to delineate A as being the largest denominator. And then typically we would put that first, but it doesn't have to be first. So you want to look for the largest denominator in your ellipse. But on your hyperbola, the first denominator will always be A. Okay? And it does not have to be the largest. Okay? How we differentiate the direction that it opens is by which term is first, and then the other one is being subtracted. So if we're subtracting y and A is positive, that's what gives us our horizontal hyperbolas. Okay? When x is positive, that's our horizontal hyperbolas. When y is our positive term and x is being subtracted, that's what gives us our vertical hyperbolas. So we're still kind of looking at some of those details really carefully to determine which direction it opens. Just like with everything else, h and k is still the center. Okay, so there's nothing new with that. Nothing different. The relationships with A, B, and C are very similar to the ellipse, but we call them something different. Instead of our major axes, okay, we don't really have a major axis anymore. First of all, because A doesn't have to be the biggest value. Okay, it can be smaller, so we can't really say major, because it's not always the largest. Okay, so instead of calling it a major axis, we call it a transverse axis. Okay, it still goes from vertex to vertex. So the major axis and the transverse axis play essentially the same role. They go from vertex to vertex, and half of that is our A value. So from center to vertex is our A value. Okay, just like with our ellipses. Our C value is still center to focus. C value is still center to focus. All right, so that's the same. The B value slightly different, same idea though. Okay, we don't have a minor axis, we have what's a conjugate axis. The conjugate axis is still going to be perpendicular to our transverse axis, just how the major axis and the minor axis are perpendicular to each other. But it's slightly different. It doesn't lead to any particular point. But what it does do is create the dimensions for something we call the fundamental rectangle. And that's this box here. Okay? Our conjugate axis gives us that other dimension on the perpendicular side to our vertices. And what's important about that box is that it gives us these asymptotes that tell us kind of how wide or narrow our hyperbola is going to open. And so if we look at this fundamental rectangle and we draw lines that go directly through the center and the corners, we get these asymptotes that tell us kind of where our graph is going to open and how wide it's going to be. And it gives us those bounds. So when we're identifying graphs or trying to graph on our own, we need to know where those asymptotes are located. The equations for those asymptotes are just lines, so we have linear equations for them. The only difference between the two is the slope. Okay? They're always going to pass through the center of our hyperbola, so we have the h and k there still. The only difference is the slope. And the slope is either going to be the b value over a or a over b. And that's going to be dependent on which direction our parabola opens. If our parabola is horizontal, it's b over a. If our parabola is vertical, it's a over b. That's the only difference. And if you forget which one it's going to be, I'll show you how we can use the fundamental triangle to figure that out. Okay? Or I'm sorry, fundamental rectangle. The fundamental rectangle makes it really easy to figure out what slope we're going to use, and then everything else in the formula. Okay? Last similarity, but slightly different. We still have a Pythagorean relation, but because our foci are going to be past our vertices, that means our foci has to be that largest value. So C will be larger than A and B. So it will be more similar and essentially identical to the Pythagorean theorem. Okay, so we're switching A and C back again. All right, so that's another kind of little detail. So as we go through these, you should see a lot of similarities in what we've been doing with the ellipses, as well with the circles and the parabolas. There's a lot of crossover. It's attention to detail that's what's going to make or break you at the end of the day. Okay? There's a lot of little details that are slightly different, but the overall processes are very, very similar. So we'll start with some graphing. Whenever we're graphing, what's the first thing that we want to find? Center. This one has a nice, easy center. Where's our center? 0, 0. We're not adding anything to h, or for x. We're not adding anything to y. We don't have an h or a k. So we've got our center at 0, 0. Okay? So we want to start with center. Okay? Just like with our ellipse, our vertices, depending on which way we open, are going to be from our center. If we're going horizontal, plus and minus to the x value. If we're going vertically, we're going to add and subtract from the y value, given our center. So from our center, we need our a value. What way does this parabola, what direction is this hyperbola going to open? Is it going to be horizontal with left and right, or is it going to be vertical with up and down? Horizontal. Horizontal. Why do you think it's going to be horizontal? Not because the a is bigger, but because the x is first. This one's going to be slightly different because of that subtraction. We're looking at what's first. So x is first, so we're going to be horizontal. Okay? A is always first on our ellipse, so a squared is 81, meaning that a is what? 9. So our vertices will be located at our vertex plus and minus 9 on the x value. We're going horizontally. If we were vertical, we would add and subtract to the y value. So our two vertices are at 9, 0 and negative 9, 0. 9, 0, negative 9, 0 for our vertices. Okay? What's if 9 is our a value, what's our b value? B squared is 64. Therefore, b has to be 8. Okay? Now, our b value is not going to give us any particular point, but it's again used to create the boundaries of that fundamental rectangle. It gives us that conjugate axis length. Okay? It gives us that conjugate axis length. We're going to go 8 above and 8 below our center. So what I'm going to do is I'm going to draw a dotted line here and there. Okay? So those are the upper and lower boundaries of our fundamental rectangle. 8 above the center and 8 below the center. That gives us that conjugate axis. And so what we can do is we can use our vertices to do the left and right boundaries. And now we see how our rectangle is formed, except I went way too far on that one. Much better. Okay? So that's the boundaries of our fundamental rectangle. corner to corner is going to give us our asymptotes, but we'll do that part. Okay? Our foci is, again, we use our value of C. So our foci will be from our center plus and minus the C value in the same direction that we go for our vertices. So if our vertices are left and right, our foci are left and right. If our vertices are up and down, our foci are up and down. They will be past our vertices on this type. So here we'll use our Pythagorean relation. This time C squared does equal A squared plus B squared. All right, what is A squared? What is B squared? So C squared equals what? 145. Okay, so C will be the square root of 145, which is irrational, but it is approximately 12, which is what we'll need to graph the foci. To get the exact value of the ordered pair, we will plug in the square root of 145. So we'll have negative square root of 145, comma 0. 0 minus root 145 is 45. And we'll have positive root 145, comma 0 as the exact locations of our ordered pair for our foci. So again, approximately negative 12 and 12, just a little bit, like barely even past, not even noticeably past. It's essentially 12. 144 is, square root of 144 is 12. So it's very, very close. All right? So we've got our center, we've got our vertices, we've got our foci. And again, our graph is going to open from our vertices. So it's going to open left and right from our vertices. But to figure out how wide, we have to have those asymptotes. So I'm going to show you, if you forget which of the formulas it is, I'm going to tell you right now, it's going to be B over A, not the A over B one. But if you forget, okay, start at your center and figure out what is the slope if I go from the center to one of the corners. Okay, slope is rise over run. And so I go up how many units to get to the top boundary of my rectangle? 8. And then how far to the right to get to the right boundary? Not 8. 9. So I went up 8 and right 9. I went up 8 and right 9. 8 was my B value. 9 was my A value. So you can use that box if you forget what the slope is. If you know what the slope is, you don't need to draw the rectangle, but it helps if you can't remember. Is it going to be A over B or B over A? That's the whole point of that rectangle, okay, is to help us get that slope. And so we know that our lines will be plus and minus 8 over 9 x. What's h? 0. What's k? 0. So we're going through the origin, so we don't need to fill in the rest of that. That is both slope, those are both lines of our asymptotes. Okay, so both the asymptotes are 8 over 9x and negative 8 over 9x. And so we can take the ruler, straight edge of any kind, and just try our best to get an asymptote there, and then the other there. Doesn't have to be perfect, but should be pretty close. And then our hyperbola is going to move out from the vertices and kind of try and hug the asymptotes. All right, it won't get super close super fast, but we'll go out and up in that direction, and then down and out in that direction, and then up and out in that direction, up and down in that direction. And so that gives us our hyperbola.
Do they ever touch?
No, they will never touch. And they will never cross those asymptotes. Those are kind of like fences that'll never go past. They will never touch the asymptote, and they're never going to come back around. So it's always going away from each other. Okay. So similarities A, B, and C for finding those key values. Just how we use them is slightly different.
Can I just write down that one?
So this is a better picture. We use Desmos to kind of get something a little bit more accurate. So the dotted lines, you can see that's going to be our fundamental rectangle, as well as the two asymptotes going directly through the center and the corners. We got our vertices plotted as well as the foci, and we see how it starts to approach the asymptote, and as we zoom out more and more, it'll get closer and closer and closer till it looks like it's essentially on it, but it never does actually cross it. All right, so where are we going to start here? 0, 0. Center is at 0, 0. We'll move off 0, 0 later, but right now we'll just start nice and simple at 0, 0. Okay? What direction is this hyperbola going to open? Up and down. Yeah, up and down. It's going to be vertically because y is first. We're going to be vertical because y is first. So that means when we find our vertices, we're going to have to add and subtract a from the y value this time. And our foci will add and subtract c from the y value. So our foci will add and subtract c from the y value. Our vertices will add and subtract a from the y value to get those key points. Okay? All right. Now again, remember where A is located on our hyperbolas instead of our ellipses. What is A squared? A is 2. What's A squared? 4. On our hyperbolas, A is always first. A is always first on our hyperbolas, no matter what size it is. So A squared is 4. A is 2. What's B squared? Process of elimination. And then we can use Pythagorean theorem to find C. Let's go ahead and find C and knock that out. So we got 4 plus 25. So C is the square root of 29, which is approximately 5.4. We'll need that just for graphing the point. We'll use the exact value for the ordered pair. We'll use the estimate to plot the point. So vertices, add and subtract A from the y value because we're going above and below. So we'll add and subtract 2. So we get 0, 2. And 0, negative 2. There's our vertices. Foci, same thing but with C. Add and subtract root 29. So we get 0, root 29, and 0, negative root 29. It's about 5.4, so we're going to go up and down. About 5.5-ish. There's our foci. Oops, that one's too far. There we go. There's our foci. The square root of 29. From center. Always from center. A, B, and C are always measured from center. I'm adding and subtracting A and C to get our vertices and our foci. So A was 2, so I added and subtracted 2 to go up and down. And here I added and subtracted the square root of 29 to get our foci up here and up here. Okay. All right, so now we need the boundaries of our fundamental rectangle. Let's do that in yellow. Okay. So my vertices give me that upper and lower bound. I just need to figure out how far left and right I'm going to go. Be 5. Yeah, 5 left and 5 right. So the left and right bound, that's based off of the B value. So we're going to go left and right 5 units to get our fundamental rectangle. And that'll make the boundaries of that box. And so to draw our asymptotes through those corners. Okay, so through the corners will give us our boundaries, and then we can fill in the rest of our graph. So starting from our vertices, go up and to the side, up and to the side. Okay, starting to hug those asymptotes. Since we have a vertical hyperbola, our asymptote will be plus and minus a over b, x minus h plus k. Because our slope, again, is rise over run. Let me do that with my highlighter. Let's do it green. Okay, we're going to go up 2 and right 5. Up is our a value towards the vertex. Right is the b value, giving us that right-hand boundary. So we know our slope is going to be a over b. So that's how that rectangle can help us again. Y plus or minus, our a value was 2, our b value was 5. H and k are 0, so we don't need to include those. As we move off center, you'll just include h and k. So whatever your center is, you'll include h and k in your line. So there's our basics of graphing. And again, A, B, and C are always based off of center. So as your center moves away from the origin, you need to make sure you make those adjustments to your vertices, your foci, as well as your asymptote equations. Okay? Again, it's a better diagram, more accurate depiction of a hyperbola. We saw something similar with the ellipse that we need to do in order to solve, so what do we do? Divide by 36. We need that denominator, or I'm sorry, not the denominator, but we do need denominators. But we need it equal to 1. We have to get our equation equal to 1. So we end up with x minus 1 squared over what? Minus y minus 3 squared over equals 1. Alright, let's find center first. What's my center? 1 what? 1, 3. H and k. There's negative h, there's negative k, so switch your sign. Center is 1, 3. What direction are we opening? To the sides. X is first, so we're opening to the sides. So, quick little sketch. If our center is at 1, 3, our vertices will be left and right that a distance. So we're going to add and subtract from x or y? X. What's our a value? A was 3. So from center, we add and subtract our a value from x. So our 2 points will be what? 4, 3. What's the other one? Negative 2, 3. Okay, and there's our vertices. Foci will be the same, but instead of a, we're going to use which one? What value gets us our foci? Not B. C. We have to use C. We need to solve for C. 9 plus 4 equals c squared. That's a squared plus b squared equals c squared. So we get 13 equals c squared. So c is the square root of 13. So we add and subtract the square root of 13 from 3. And there's our foci. And we got it. Center, vertices, foci. The only thing we needed to use B for was to find C. It's not graphing. B is useful for graphing, but we're finding our asymptotes. I don't need it to find the vertices and foci, and all it asked for was center, vertices, and foci. Okay. B is used to find C, B is used to find the asymptotes, but we don't need it for anything else. Okay, we're in general form. What do we do? Add 4 to the other side, factor out GCF. What's the general process that we're trying to do? Complete the square. Complete the square. So when we're looking at our hyperbolas, we want to pay attention to which squared term is negative, because you need to make sure that one's second. So if y is negative, x will come first. If x is negative, y will come first. Because we have that subtraction. So you need to make sure that you put those in the right order. Y is negative, so x will come first. Positive for them. Okay. All right, what do we do before we get our boxes? Which is what? What are we going to factor out? 2 things. 9, and what else? Take the negative. So we factor out the 9. Nope, just the 9. I still need x squared. I just don't want that leading coefficient. So I have x squared what? 4x. Then we can put our box. We'll factor out negative 4. Gives us y squared what? Minus 2. Okay. On the right side, we get 4 plus, find box, minus 4 in the box. If we factor it out, negative 4. What goes in our first box? What goes in our second box? 9x what?
Minus 2 squared.
Minus 4y equals
I use too much for me right now. You said 36. Well, I did say 36.
That's why I wrote it down. Last step. Divide everything by 36. X minus 2 squared over minus y minus 1 squared over equals what's our center?
2, 1.
What's A?
4, 2,
What's B?
3.
What's C? Find it.
How did you do B?
A squared, B squared, square root of root 13.
Oh, because it's
A
4
squared,
plus 9.
4 plus 9. That's square root.
Not 3 equals 2.
Alright. Which one are we going to use to find our vertices? A to find our vertices. Up and down or left and right?
Left and right.
Okay, so from center, what 2 points are left and right A units away?
4.1, 4.1.
A points away.
That was a beautiful one. That was roll time.
Okay, what are we going to use to find foci? C. So we're going to have 2 plus root 13, comma 1, 2 minus root 13, comma 1. Foci. Yes. On the test, you can do plus or minus. On math lab, you have to write them separately.
I did plus minus on that.
Sometimes it works, sometimes it doesn't, depending on which book I pull that question from. So, especially if it says use commas to separate answers, I would recommend writing it separately.
I love gamble. A little gamble.
A little gamble that possibly results in you having to do the whole thing again. Yeah, always fun.
Little gamble.
All right.
Roll the dice. Roll time.
Find a hyperbola with the given center, vertex, and focus. Center, 2, 3, so right and up. Our vertex is where related to our center? How do I get to my vertex from center? 3 up? 3 down? 3 left. 0, 3. There's our vertex. So if we have center and vertex, which direction does our hyperbola open? Side to side. This way and this way. They also give us the focus 5, 3. That's in the opposite direction. So we have another vertex here that we don't know, and another focus over here that we don't know, but we don't need them. We just need a vertex and a focus. So we know our center, which means we know H and K. We know we're going side to side, so which variable comes first in our formula? X. Okay. What's H? So X minus 2. What's K? Minus 3. Now we just need A and B. In order to find B, we're going to have to use C. A measures what distance? Vertex of center. How far away is our vertex from our center? 2 units. Went from 2 to 0. So A is 2. Center to focus gives us what? It is 3, but it gives us which letter? C. Focus. Focus. So C is 3. How do we find B? A squared plus B squared is C squared. 4 plus B squared, 9, B squared equals, my brain, 5. So B is the square root of 5. I don't really need square root of 5 because I'm going to put in B squared. So what's our first denominator going to be? 4. A squared. A is 2. A squared is 4. What's our second denominator going to be? Square it. Nope, square root 5. You can square root it, get B is square root of 5. You can square it, you're right back where you're at. So I know what it's 5. So we plug it in. And we got our equation. Sure. Alright. Given vertices 0, -5, and 0, 3, which direction is this hyperbola going to go? What values are changing from vertice to vertice? Y. So it goes up and down. Y is changing. So we're going up and down. Here and here. 0, -5, and 0, 3. Where's our center? The 0 part's right. Nope. -1. Midpoint. Add your y values, divide by 2. Add the values, divide by 2. That gives you your midpoint. So we've got center. It's halfway. Half. Half the distance. Okay? We need A and we need B. What's A? A measures what distance? Vertex to center. How far away is our vertex from center? 4. C measures what? Center to focus. How far away is our focus from center? 5. So what's B going to be? B squared is 9. 3. All right, what variable is going to be first in our formula? X or Y? What's K? What's A? Well, it was -1, but the formula is minus, so it changed the sign. What's A? A squared is 16. What's H? 0, so we don't need it. X squared over, what's B? B squared is 9 equals 1. Now real quick, I know the bell's going to ring about 30 seconds, so I'll put this back up in a minute if you stay, but I want to talk about something real quick. That very last slide. You'll want to be able to look at equations and determine which conic section it's going to be. So, listen very carefully. You want to try and group your variables. If you've got squared terms, it can't be a parabola. If they're both squared, no parabolas. Circle, ellipses, or hyperbolas. The signs and the coefficients are going to make the biggest difference. So if we take y squared and move it over, don't leave, we have positives squared on both of those. That's going to mean that it's either going to be a circle or an ellipse. If we have a leading coefficient, it can't be a circle. It has to be an ellipse. When we move it over, if we have a subtraction, it has to be a hyperbola. If one of our terms is not squared, it must be a parabola. And if we have two squared terms and no leading coefficient, it has to be a circle. All right, let me leave.